Okay, so today we're going to finally introduce the unit circle. So you'll see here I have a circle drawn on an XY axis, so it's centered at the origin at 0, 0. Now the reason this circle is called the unit circle is because the radius of the circle is equal to 1. So anytime you're talking about the unit circle, the radius is always equal to 1. So for example, if I was looking at this point right here, so where the circle intersects the x-axis, this coordinate, if I went 1 unit to the right, would be written as 1, 0. And we know that this is either 0 degrees, or if you go completely around the circle, 360 degrees. Likewise, if I went up 1 unit to 90 degrees, this coordinate would be then 0, 1, because I did not move left or right at all, but I went up 1 unit. At 180 degrees, this point right here would now be -1, 0, because we went left 1, we did not go up or down. Then down here at 270 degrees, it would be 0, -1. Now, many unit circles, and in this course as well, you need to be able to do this in both degrees and radians. So I'm going to go back and actually put the radian measurements as well. So 0 degrees would just be 0 pi. 90 degrees, remember, is pi over 2. 180 degrees is just pi. 270 degrees is 3 pi over 2. And then 360 degrees is 2 pi. Okay, so today we're really just going to focus on the first quadrant here. So anytime you look at a unit circle, there's 3 angle measurements within this unit circle that you're going to see: 30 degrees, 45 degrees, and 60 degrees. I'm going to start with that 30 degrees first. So I'm going to switch here over to blue just to try and color coordinate this a little bit. So I am assuming that this angle measurement here is 30 degrees. That's what this marks here. So from the x-axis up to the terminal side. And inside my unit circle, I want to figure out what the coordinate of this point is where the terminal side intersects that circle. So I'm going to make a triangle, kind of like you did with point and plane and our reference angles. So with this triangle, I'm going to put this off to the side here. So I know this angle measurement is 30 degrees. Because I have a vertical line intersecting this x-axis, this creates a 90-degree angle, and that leaves me with a 60-degree angle up here. And we said already that the radius of the circle was equal to 1. So I know that my hypotenuse here has a measurement of 1. Now, in order to figure out the actual coordinate point where the circle intersects this terminal side, I need to figure out how much I'm moving to the right and how much I'm moving up. So I really need to figure out these other 2 sides here. Well, remember from yesterday when we talked about our 30, 60, 90, and 45, 45, 90 triangles. I could label these as, I'm going to go with S this time around. So across from my 30 degree is S, across from 60 is S root 3, and then across from my 90 degree was 2S. And then this will help me actually figure out the X coordinate and then the Y coordinate. And that's why I didn't use X in this case. So if I'm told that 2S equals 1, I want to solve for S. So I'm going to divide both sides by 2, and I end up getting S equals 1/2. So that means that this length over here, this vertical distance, is 1/2. And then to figure out the horizontal distance, I'm going to substitute 1/2 in for S. So 1/2 times the square root of 3, which would actually be written as root 3 over 2. Because I can write this as a fraction. 1 times root 3 is root 3. 2 times 1 is 2. So the coordinate, I would write this as, so I go over to the right, so this horizontal distance here, my x, is going to be root 3 over 2. And then my vertical distance was 1/2, so comma 1/2. I'm going to do the same thing now for my 45-degree angle. So I'm going to switch over to green here. So I'm going to draw my triangle out here. So we know that this is 45 degrees. Here's our 90 degrees angle, and then that means this is also 45 degrees. And then again, our hypotenuse is equal to 1 because this is part of the unit circle. So labeling my sides here, across from my 45-degree angles, I have S, S, and then across from the 90 is S square root 2. So if I'm told that S root 2 is equal to 1, I'm going to do this off to the side so I have some more room. I need to solve for S. So I'm going to divide both sides by square root of 2. So I get S equals 1 over root 2. But if you can remember from last week, we really don't want to see those radicals in the denominator. So in order to rationalize this, I multiply by square root of 2 over square root of 2. So 1 times root 2, I get root 2. And then in the denominator, root 2 times root 2, or the square of 2 squared, ends up just being 2. So that means that this side here is square root of 2 over 2, as well as this side is square root of 2 over 2. So if I want this coordinate point back on my unit circle, well, I went to the right, root 2 over 2, and then I went up, root 2 over 2. So that means this is square root of 2, root 2, divide by 2, comma, root 2 over 2, sorry. Okay, so my last one, that 60-degree angle. So I'm going to grab my orange marker here. So again, I have a triangle here. And I know that this angle here next to my origin is 60 degrees. Here's my 90, and that means this is my 30. My hypotenuse has to be equal to 1. So likewise here, I'm going to label all my sides. So across from my 30 is S, across from 60 is S root 3. And then across from my 90 is 2S. So my hypotenuse is that 2S side. So because 2S equals 1, if I divide both sides by 2, that means S equals 1/2. So I can substitute that in everywhere else for S. So this horizontal distance down here is going to be equal to 1/2. And then that means this vertical distance is 1/2 times the square root of 3, which is root 3 over 2. Because I'd want to write that as one fraction. So putting root 3 over 1 and then just multiplying across. So this time I'm going over to the right 1/2 units and then up root 3 over 2. So when I put that into my unit circle, my coordinate here would be written as 1/2 comma root 3 over 2. So that is the first quadrant of my unit circle. And really quickly, I just want to go back and put the radian measurements. So 60 degrees is equivalent to pi over 3. 45 degrees is equivalent to pi over 4. And then 30 degrees is equivalent to pi over 6. So sometimes you'll see this referred to as your pi over 6 family, pi over 4 family, and pi over 3 family. And we'll see if you can build that first quadrant in the unit circle. That's really going to help you then build the rest of the unit circle as well. And we'll talk about the remaining parts of the unit circle tomorrow.